So data as a fuel, which is the most important part in this ecosystem, its value is being highlighted. As people begin to pay more and more attention to their privacy, and individual information has been the most hotspot in users' rights and interest protection field in a worldwide scope. So according to the Internet Individual Information Protection White Paper published by the China Academy Information and Communication Technology, it claims that in recent years, the West and Japan and some other countries have related or amended related regulations about individual information protection, in which the famous GDPR, which is issued by the European Union, is known as the most rigorous regulation in data protection field. The GDPR claims that for those non-compliant companies, it may have to face a fine of up to 20 million or 4% of its annual turnover, whichever is higher. So for any company, even the Facebook or Google, that can be a very significant amount to afford. So we can see that no matter from a perspective of individual or from the legislation, things are moving in the direction of the privacy protection. However, life is always cruel, yeah? And the reality is, as the information chain goes, and also because of the huge commercial interests, the events of privacy invasion have been constantly emerging. So how to protect the data privacy in a data flow and to make them shared and computed safely is still in a very early stage, and we need to explore it. Okay, here are some data leakage cases. In March this year, Facebook was exposed to provide over 50 million users' information to a company called the Cambridge Analytica, and it provided the political advertisement to the targeted users so as to affect the American presidential election in 2016. And for business side, some enterprises may illegally collect or make use of the user's data, like some traveling or hotel, e-commerce platforms in which the price displayed to the old users are always high than that displayed to the new users. And for the same user, the price before ordering may be higher than that after ordering. So the logic behind this is that the website will generate precise portraits based on the user's personal information and some history orders and some traveling footprints and etc. And then it will calculate the price acceptance range and the region demand using the big data technique. So there's no doubt kind of illegal usage of the individual data, yeah? And besides, several big companies have been reporting data leakage incidents in recent years. For example, over 47 gigabytes of the medical data of Amazon was accidentally made public, which leads to a 115,000 patients' information exposed. And Uber, Yahoo have been fined big amounts because of its data leakage. So in China, the security events it also becomes more frequent, like Huazhu and Starwood hotels, whose lots of user data has been stolen, and all these instances makes the data protection in a very rigorous situation. So, okay, with that much background, we kind of know that the data should be protected, but you may ask where and how. So next, let's have a look at some scenarios that you may be familiar with. First is the big data analysis. You must know that we can get lots of meaningful results using the big data technique. For example, for an online shopping mall, the platform may collect large amounts of the user's data, such as the personal information and the purchasing behavior and so on. So by analyzing this data, the platform can accurately recommend amenities to the users, and they also can serve some advertisements. So in the meanwhile, the enterprise is also a data owner with the large amount of valuable data. One kind is the data of the users on the platform, and the other kind is actually the platform itself's data, like the website traffic, the page view, or the daily view user, etc. So they need to dig into this data and get something useful. But in fact, most enterprises, they do not have the ability, such kind of technical ability. And they need to rely on some third-party data service providers to do this data analysis. So another scenario is the data exchange. Basically, it can be differentiated into two types. One is a centralized data exchange. And in this type, the data can host their data to the data exchanges. And then after some processes like the evaluation and the filter, the data buyer can purchase this data. So in China, actually, there are already some big data exchanges backed by the governments, such as the Global Big Data Exchange in Guiyang and the Shanghai Data Exchange Center. In China, there are some data exchanges backed by the governments. So, such as the Global Big Data Exchange in Guiyang, and also in Shanghai, is the Shanghai Data Exchange Center. So also there are some companies that focus on the data resources, like the Data Tang and Data Duoduo, etc. So, but we have to admit that all these companies and all these exchanges, even including this industry, are still in a very early stage. They are still exploring the right way and the right methods. So as the data protection regulation becomes more strict, they may face the risk of violation. And the other is the P2P data exchange mode, and it is also a very hot topic called the Web 3.0. And it is also advocated by Sir Tim Berners-Lee, the inventor of the World Wide Web. Its main idea is actually that the ownership of the data belongs to users, and users can gather all their own data from the internet and store them locally, and then they can authorize others to use this data with paying some fees. And in both modes, actually, the privacy is always the first thing that we have to care about. Okay, so let's get back to the issues of current scenarios. First is the data analysis. We need to think about how to guarantee the privacy during the collection and processing by the third-party data, the collection and the processing by the third-party data analysis platform. And in the data exchange scenario, no matter the centralized or the decentralized mode, the data will be evaluated and filtered. So how to guarantee the privacy during this period? Okay, here are some existing privacy solutions. Common way is the data desensitization. So it simply takes out the sensitive information from the raw data and then hand it over to the data processor. The advantage is that we can process the plain text directly, so it may have a fully functionality. But sometimes it is very hard to do a very rather complex desensitization. So, and also it may lose some useful information. So it may be not enough for data analysis. And another is MPC. It is short for the Secure Multi-Party Computation. It's proposed by academician Yao Qingzhi, who is one of the Turing Award winners. And it mainly discusses how to do cooperative computing among multiple parties in a very secure way. So there are some mathematical algorithms, including the homomorphic encryption, the zero-knowledge proof, etc. So let's take a look one by one. Actually, the homomorphic encryption is a form of encryption that allows computation on ciphertext. It will generate an encrypted result, which when decrypted, it will match the result of the operations as if they have been performed on the plain text. And its benefit is that it can protect the privacy of the plain text during the computation process, but it also its deficiency is very obvious. Is that it can only support some simple operations like the addition, subtraction, or multiplication. So it has a very limited functionality. And also the zero proof knowledge. The zero knowledge proof is also a very known method in cryptography. It allows one party who is the prover to prove to another party who is the verifier that they know a value X, and without conveying any information apart from the fact that they know X. So simply, I will give an example. Suppose I need to prove I have a password of a safe box, and I can't let you know the password, right? So with the zero knowledge proof, I should open the I will open the safe box privately with your access, and then I will take out something in the safe box, and that thing is that you know that is originally in the safe box, and then I will lock out the safe box and show the stuff to you, so that I can prove I have the password of the safe box. So zero knowledge is good for verification without disclosing some key information, but actually its deficiency is also obvious. The interaction process is very complicated, so the performance may be several orders of magnitude slower than the native execution. And there is another method called the differential privacy. It's basically adds some noise to TE technology. First, let's talk about blockchain. I'm sure everyone here knows blockchain, yes? And everyone knows that it's decentralized, and it's trustless, and it's unalterable. And these characteristics make blockchain very suitable for the magnetic storage, the authorization, and source tracing, etc. However, blockchain, blockchain is always blamed for some deficiencies too, because these characteristics does not come for free. So the deficiencies include the poor performance and scalability, just as Patrick introduced, and also the privacy issue and the limited functionality. So I will dive into this one by one. First, consensus. You know that the consensus without trust is actually very expensive. So nowadays, public blockchains do not trust any individual node. This leads to broadcasting messages among the network, and each node needs to store all the data. So, which may fundamentally limit its performance or the poor performance and scalability. Current public blockchains also have the privacy issues, which is again fundamentally bonded in its trusted model. So, since every attendee needs to see every other's transactions to achieve global consensus. So for example, in Bitcoin, so all users is a public node. And since every worker needs to execute all the transactions of smart contracts, so for example, in Ethereum, so all the data and computation has to be public too. So essentially, there is no privacy under this model at all. So due to the lack of privacy and poor performance, current public blockchains have very limited functionality, which prevents many suitable use cases from being deployed. Maybe think about a financial company who wants to do stock trading on public blockchains. I know this is great. Suppose you do it. The first thing that you will notice that it may take tens of seconds to finish one trading, and in Israel, maybe in Israel, several seconds. Yes, it sounds not that bad, but in fact, in addition, you have to wait for several minutes to be confident or confirm that your transactions actually went through. And at that time, it's highly likely that the stock price has been dramatically changed. And on the other hand, we find that some trading companies start to trade in your trading policy. So because your trading policy is supposed to be highly confidential, is actually totally public on the blockchain. So anyone can copy your policy. So we want to ask, can we tackle this problem? I promise I will come back to this later, but before that, let's take one step back and rethink the trust model. So in 2008, actually, there's a time the Bitcoin white paper is out. In 2009, when Bitcoin officially kicked off. At that time, we don't actually have much trust on. However, for now, in 2018, TEE as the trusted execution environment is widely deployed. So it's about the time to reconsider the trust model. But before that, let me briefly introduce what is TEE. Literally, TEE means trusted execution environment. Okay, I know that it tells you nothing. But basically, TEE is a secure area provided by the mobile or laptop chips, which can ensure the integrity and confidentiality of the data and the code inside. And the programs outside TEE, even the operating system, cannot access the data inside. Actually, you can imagine TEE as a black box in the chip of a mobile phone or your personal computer. And for those data that needs the financial level security, such as the fingerprints, your Face ID, or your payment passwords, are stored and processed actually in TEE. So there are multiple implementations of TEE right now. In mobile, it's mainly ARM Trust Zone, and as for the PC chips, there are Intel SGX, and AMD SME, SEV, etc. And Intel SGX is actually has already been within in most of the Intel chips, and ARM Trust Zone is pretty much in all your smartphones now. So now everything is ready. It's time to introduce our TIX solution, which combines the TEE and blockchain techniques. Here is TEE architecture. TEE provides a distributed second layer solution based on the current public blockchain. And by decoupling computation and settlement, we can tackle the problems we just mentioned. There are three roles in TIX network. A service provider will deploy services, and you can imagine, you can think that just like dApps, okay? And in the network users are those who will have the requirement to invoke the services, and the workers will provide the computing power. So the service providers and workers are required to have the trusted environments so as to ensure the privacy and integrity of the code, data, and the process of the computation. And between user and worker, there will be a secure channel to transfer the data and the result. And we have a dispatcher to distribute the computing tasks to the workers, which means that the workers can contribute their computing power to different tasks without redundant computation. So as a result, it can improve the scalability in this network. So verification is always an important step, So in original public chains like Ethereum, is mainly using redundant computation and global consensus. However, as we have discussed, that it may lead to poor scalability and waste of the computing power. So here we use TEE. Once the worker finishes its task, it will generate a proof of work and assign it with the private key stored in TEE, which will be verified in a bounty contract that has already been deployed on the public blockchain. And after verification, the worker can prove that he has executed the right code with the right data. And then it will settle with a smart contract of the public blockchain and get some payments. So now, let's record the previous trading example. Now you have your trading policy encrypted, and then you can throw it in a TEE, which can be running at any possible corner of the world. And that machine knows nothing about anything. So your code is executed actually in a very safe environment, and it has a native speed, and the transaction will be committed constantly. So back to the reality, let's see how the text can protect the privacy within a real data flow. So in our ecosystem, we have the data owner, the data demander, and some third-party data analysis platform. And there will be some steps like the data uploading, the collection and analysis, and also with the service deployment. So we will guarantee the data privacy in these aspects. First is the privacy of data storage and computation. And also, we have guaranteed this permission control, which means that the data owner can decide how much data he would like to share, as well as to whom. And once, if he does not want to share anymore, he can also take back the authority. So let's go through the data processing. Before that, we suppose that the services deployed by the service provider is already there. And the step, for the first step, the user will request to the public chain and get the service information. And then he will upload the data and invoke the services he wanted. For the second step, the dispatcher will check the listing of the request and distribute the tasks to the workers. And then also it will have some error and timeout handler. And for the third step is the processing of the data. Actually, the worker will achieve and check the data validity and execute the target services and return after computation, it will return the results, and also with the verification. And for the last step, the proof of work and some logs and some metadata will be uploaded to the public chain. So in a short summary, our privacy solution actually can ensure the privacy in a data flow by combining the blockchain and TEE technology, which includes the secure storage, the data sharing, and the computation. And we can guarantee the integrity and the confidentiality. And also we can support general purpose computation, and we have the native performance. So here are some practical use cases. So you must have tried the face recognition in banks or some financial apps. So basically, they will get your Face ID and rely on some third-party service providers to do the identity authentication. So your Face ID actually may have the risk of leakage, just as this time. Because you are not sure what the third-party service provider will do with your data, like secondary trading or something like that, which can make money. So now, by using TIX, the service provider will deploy the recognition service in our TIX network. And all the codes, models, and and your personal data will be processed in the trusted environment so as to protect the security and the privacy. Another is the data analysis for the enterprise. Simply, the service provider will deploy the data analysis service in our TX network, and the enterprise will invoke the service by the same way. So it's quite convenient and compatible. So, however, as you know, TEE is also doubted sometimes by people for its non 100% security, like some exposed loopholes. So for the secure side, we provide a software and hardware co-designed enhancement solution based on the existing TEE solutions, based on the existing TEE infrastructure. So the hardware basis is actually the Intel SGX. As mentioned, is an isolated execution environment in Intel CPU. And compared to some other TEE implementations, SGX can also defend the physical attacks. And so we'll talk about SGX later. And on the software side, we provide a software TEE solution, which includes the stack analysis and the mutual untrusted isolation, which means symbols. And also, we provide system-level side channel defense. So I will give you an introduction of Intel SGX. So actually, SGX is a hardware TEE solution provided by Intel. And it is actually has been already widely deployed. All the Intel CPUs for personal computer which is produced since 2016, has already been supported with the SGX module. And there is a secure execution environment called Enclave in Intel SGX. Enclave is actually a complete execution environment which can run codes and store the data. And for any external programs, it cannot access the data code in an enclave. And the memory for enclave actually is encrypted. So it means the private key is stored actually inside the CPU, but not in the memory. And it can resist the physical attacks. But Intel SGX actually has some deficiencies. The first, it cannot prevent data leakage from internal applications. And second, it relies on the operating system for some basic services like the network I/O, file system accesses, and virtual memory management. And also, it cannot defend the side channel attack. So we designed an enhancement solution for the Intel SGX on the software side. So first, as mentioned, we will do a static analysis for the service code, which can prevent the programs inside to leak data intentionally. Actually, we do some examinations of the I/O operations so we can detect it. And another is a mutual untrusted sandbox. It means that we can guarantee that the code and data in the enclave will not be stolen by the outside. And in the meanwhile, if the code inside the enclave is malicious, it can either not affect the outside operating system. So we implement this mainly by examining the interaction interface between the internal codes and the internal codes in enclave and the operating system. And also we can resist the LEGO attack by a malicious operating system. And besides, we also provided a side channel defense based on our virtualization research achievements. Actually, the side channel attack means you can transfer or steal the privacy data by detecting the status change of the cache or the branch predictor. And we solve this problem mainly by trapping or catching the enter and the exit of the operation of the enclave. And also, we isolate the status of the cache and the branch predictor. So for the trusted node in TICS, another question is how to ensure the reliability. So it can be divided into three aspects, actually. The first, we need to verify that if the targeted services is protected by our soft TE. So we mainly do this by using the TPM, which means the Trusted Platform Module. Actually, is a widely used dedicated device. And the second is to verify if the target service code is running in an enclave. So this is mainly based on the remote attestation service of Intel SGX. But we also propose our attestation method, which does not need to rely on Intel. And besides, when verifying enclave, we can achieve the hash of the code actually, so that we can verify if the targeted service code is actually running. So one more thing is that we have already open sourced some computation services based on our TICS distributed trusted environment. And currently we support the SSSP and the linear regression algorithms. And our interface is based on HTTPS, and we support the C, C++, Python, and Java. And all the computation data is executed actually in TE, which means Intel SGX. So everyone can join as a computation node, and it's currently totally free at present. And we promise more will be coming. And this is the address. So if you are interested, you can have a check. So let me have a brief introduction about our team. Actually, we are from the top research group in China Academy, and we have 7 years experience on TE research and development. And our research papers are published on top-tier conferences, including this. And the things in this roadmap is what we have done. And what we are currently doing is TICS. So that's all for my talk, and thank you very much.
Any questions? First.
So can your solution defend the false shadow attack?
Yeah, of course.
Okay. So
Foreshadows. Yeah.
foreshadow attack.
I know. So the foreshadow, we mainly solve this problem by clear the cache, L1 cache, and it's based on our virtualization method. So we have published a technical paper in our WeChat public platform. So if you are interested, you can have a look at it.
Okay, I see. And another question.
Okay.
So can the mobile devices with T inside be a worker client?
Yeah, we are planning to deploy the platform on T, but currently we are doing that mainly on Intel SGX. That means the PC first, and then the mobile.
Do you think it's practical? Is there any efficiency concerns?
Practical.
I mean, is it practical thing? I mean, do you have any comments on the efficiency of mobile devices than in the PC devices?
No. We don't have that such kind of data.
Okay.
So how do you slice the computation? For example, if I use ARM hardware if I use ARM as a worker,
Yeah.
will I earn more compared to using Intel SGX? I mean, there are two workers, one use ARM chips and one use Intel SGX. Who will be more profitable? Will that be a problem because maybe workers will all use Intel SGX at last?
I don't think there will be a problem because they both have TEE environment. That's the basic requirements to join our network.
You mean if I'm a worker, I have to have Intel SGX to be a
Currently, yes, you have. Actually, you already have because your PC, the Intel CPUs in your PC already have SGX, but you don't use it.
Yeah,
You just work with it.
what I mean is maybe next year the ARM publish a new chip and
Yeah,
it's more efficient to do private computation on that ARM chip. But
Okay.
people all flow into that flow to use that ARM chip and
Oh, I know what you mean. So yeah, we are considering to build our system based on ARM chips. That's absolutely. So
Yeah.
ARM will be our choice.
and then the following question will be like there are workers with different types of secure chips, right? Then how do you pricing the service? Like maybe if a worker uses Intel SGX, he will spend 1 minute to finish this computation task. But if I use ARM, I only need 30 seconds.
Okay. Yeah, that's a very good question. So actually the price may be based on the computation, the computing instructions actually they have done. So the difference may be the computation time and the performance, and the particular policy we will search out maybe later.
We try to intensively do not distinguish between qualities, actually. So they get to fit us, actually. Do you have questions?
OK，我刚刚看到那个上面有一个，我用中文说可能会很麻烦。看到一个就是代码检测这一项有这条实现，就是防止数据泄露被代码带出来了。对，
Static。
对。
对这一块的话，主要是就是通过一些检查 I/O 的操作。就如果是代码逻辑的话，可能现在是没有什么特别好的方法去生产。就是你主要是防止它里面的那个代码，它会不会有一些泄露里面数据的风险。那么这个的话主要是去
算完之后的结果总得出来。它计算完整个计算的程序，计算完之后的结果，它总得。
对，这个是可以通过。
但是你怎么知道那个结果里面没有带那个
你可以
信息？就是说，通常这种有没有这条实践，或是你们有做过的这种？
实践这个暂时不方便。
对，其实并不是所有的数据都一定要出来。这是第一。第二的话，如果就算要出来的话，其实也可以利用一些 differential pricing 或者这样的一些方法去控制住它对隐私的泄露。然后核心是在于要控制住它的一个 control flow 和 data flow 的一个 monitoring， 但这个是动态去dynamic去做的。static 的 check 的话，更多的是去和动态的这个做结合，然后一个互相去弥补这样的过程。
Okay, any other questions? Cool. Patrick?
I guess you get this a lot, but what's the difference between this and Oasis Labs?
Sorry, the difference between
Oasis and the company Oasis Labs, so that's making one song panel.
Oasis.
Yeah, I can never pronounce it correctly.
Okay, I know Oasis. Maybe I think Oasis will do a public blockchain. He will build the total infrastructure from the maybe from hardware to the blockchain to the apps, and we just doing layer 2.
Do you know Covalent?
Covalent.
We know
What's the difference?
Different areas covenants.
Yeah. They also do TE offline computation.
Okay.
To
So
present-
I think they do not have very practical or some landing scenarios. Currently, I don't see much.
I think Covenant is based on GPU. They care about privacy.
Yes, they also mentioned they care about privacy. Actually, there are a lot of similar projects here. Actually, besides Oasis and Core, actually, we can name another 10. Actually, so I think when we talk about the difference between these projects, I think it's a little bit hard because all of them just mentioned we use TE and blockchain,
Yeah.
but a few of them give a lot of details on what they will actually do. Yeah, so basically, it's not an easy job to figure out the difference between all these not so detailed descriptions just on their website. I think the basic idea behind these projects are that we believe TE might be a practical way to solve some privacy issues of blockchain, but actually it's not easy to find a real case, a real scenario that can leverage the advantages of all these two technologies. So yeah, so actually I think we should consider, we should find a real case and find a real problem to solve with these technologies. Yes.
我想问一下，那个就是在安卓平台上面，就是现在有那个，比如像现在手机上面，安卓有预留那个，比如 API， 在 API 去访问那种，比如像 App 提供的 Trust Zone 这种功能吗？
安卓预留 API 去访问 Trust Zone 这个，就是 TE 这个模块的功能。
有一个 API 就是叫 Global Platform， 但是 Global Platform API 的话，更多的不是用来做一些 private computation， 而是用来做一些就是一个 general 的一个 API， 非常简单，就是比如说 invoke command and return and get return value， 就是很简单的一些 API。但是
low level 的
对，非常 low level 的一个 API， 然后 theoretically 我们可以去实现一些trusted application， 然后 run in 这个 trust zone。但是现在最大的问题在于，这个是被控制的，手机厂商不会开放这个接口，至少目前还没有开放这样一个能力给所有的这个 developer。所以这里的 bottleneck 的话是在于说什么时候它能够开放。但 Intel 的话现在还是算是比较 open， 就是说只要你通过 Intel 的一些流程的话，你是可以开发一些 SGX 的应用。但手机厂商的话，你必须要一个个谈，比如说像阿里，它的这个其实蚂蚁金服，那支付宝的话，其实当时就跟华为就谈了很久，然后再做完第一个，谈完以后的话，它可能还得一直在谈，但其他都不需要谈，其实就大家都很愿意去接收，所以就推得很容易。但如果你是一个 nobody， 然后你想说我需要去在里面开发一些东西的话，其实会非常难。那因为我们自己的话，之前做的一些事情，做了一些 trust zone 的一些工作的话，是已经实际部署在手机里面的，所以我们其实之前跟手机厂商的，就是说基本上这条路的话都是通的。后续的话就谈了一些非技术的原因，比如说如果后续要分成，如果后续要开发，但 generally 这个更重要的事情是，这手机的生态行业的话会非常的复杂，比我们的一般的 PC 的话要复杂得多。
好，谢谢。
Okay, any other questions?
非常好。
I have another question. How does the user submit the data to Worker through direct network?
Directly through this secure channel. Encrypted.
You mean there will be a network connection between Worker and user?
Yeah.
So send encrypted data to the worker, encrypted data to the worker.
Encrypted.
I mean,
It will be decrypted in the TE of the worker.
in the enclave, for example.
Yeah.
Okay, go. So how do you distribute the key? You use the symmetry.
We have a KMS.
PKI?
Key management.
Key management.
You mean how to manage the key?
Yeah, how to manage.
We have
distribute the key.
Yeah, we have key management to manage these keys. Actually,
I got it. Thank you.
Okay. Any other questions? So let's our meetup come to the end.